What's up everyone, Patrick here, welcome back. Moving on to the next question. So we got to determine the value of m, n, or n. So each of these systems here of equation has infinitely many solutions. If they have infinitely many solutions, it means they're basically the same line. They're right on top of each other, so they're intersecting at an infinite amount of points. Now, multiple ways, again, you can do this. You can put all the lines in y equals mx plus b form, and then the m and the b value have to be the same if they're going to have infinitely many solutions. But if they're in this kind of format, this standard form type of format, then all the ratios of the coefficients and constants have to be the same if there's infinitely many solutions. Now, if there was no solutions, then the ratio of the constants would be different than the ratios of the coefficients. The ratios of the coefficients would be the same. The ratios of the constants would be different. But if there's infinitely, then all the ratios are the same. So notice here in this one, we have to solve for m. There's two expressions with m. And that's kind of just to throw you off. This is actually really simple because notice we could solve for m with this ratio and this ratio, right? M over -6 equals 3 over 3, like that. So we'd have 3m equals -18 after we cross multiply, so m would be -6. That's just the answer right there, right? This ratio is 1 to 1, so this ratio has to be 1 to 1, so m would be -6. You'd have -6 over -6, which is just 1. And then notice you could take this and you could check it. If I take this -6, if I plug it in here, -6 to the power of 2 is 36, times 2 is 72. So notice we'll have 72 over 72 equals -6 over -6, which is equal to 3 over 3. So all the ratios check out. So this one was actually really simple. It's just maybe these multiple m values can sometimes throw you off, right? But a lot of times it's more simple than it looks. Now, this one is going to be more complex because it's in a bit of a weird format, this second line. So this one is 3m squared x plus 7y is equal to 2. But notice here we have two expressions with x. We have mx plus 4x plus ny equals 5. And so how do we deal with this, with these two x expressions? Well, one thing we could do is we could actually factor out the x from both of these and rewrite it as m plus 4x. Because the m is just going to be a constant, so a constant plus 4 is just going to be another constant in front of x. So what we could do is instead of writing it like this, we can write it as m plus 4x plus ny equals 5. And now notice that they're lined up. And so we could just make the ratios equal. So we could say 3m squared over m plus 4, this over that, equals 7 over n, which is equal to 2 over 5, like that. So all those ratios have to be the same. And now you could just solve, so we could take these two ratios. Notice how we can't make this and this equal because there would just be one equation and two unknowns. So we wouldn't be able to get the m and n value, but we can use this 2 over 5 here to solve for each. So we would say 7 over n equals 2 over 5. Which would be 35 equals 2n. So n would be 35 over 2. That would be the answer for n. That's the easiest one I get, I feel. Because with this one, we're actually going to get a quadratic equation. There's going to be multiple solutions for it. Right? But this one, really easy. Just cross multiply. Isolate for n. So n is 35 over 2. Now the other one, we'll do 3m squared over m plus 4 equals 2 over 5. So this would be 2 over 5, like that. And then from here, we can cross multiply. So this times that is 15m squared equals 2 times m plus 4. Be careful with the brackets. You got to put this is an entire expression you're multiplying by 2. So from here, like that, bring everything to one side, so you would have 15m squared minus 2m minus 8 equals 0, like that. And so from here, what we can do is, let's try to factor this. So what we would do is we would multiply the a and the c value, which would be 15 times negative 8, which is negative 120. So what two numbers multiply to negative 120 and add up to the b value of negative 2? Well, notice negative 12 and 10 work. So we could decompose that middle term into those two, like that. From these two, what factors out? 3m. We'd have 5m minus 4. And then from these two, a 2 factors out, which would be 5m minus 4. Remember, these two brackets should always be the same if they factor smoothly. Then we could take out the bracket 5m minus 4, and we're left with 3m plus 2. That's going to equal 0. And so from here, 5m minus 4 equals 0, or 3m plus 2 is equal to 0, which means m would be 4 over 5, or m would be negative 2 over 3. So there's actually multiple solutions that work for m for this one. And if you plug in for m here, you have to plug in the same one. So either you plug in 4 over 5 here and here, or you plug in negative 2 over 3 here and here. You can't plug in like negative 2 over 3 and then 4 over 5 over here. It's got to be the same m value for both. And then the n, there's just one solution, 35 over 2. So be on the lookout for these kinds too. They could get a little bit more tricky, and sometimes you could get multiple solutions for these constants, especially if you see like m squareds. In this case, there was only one solution, but in this case, there was two solutions for m, 4 over 5 and then negative 2 over 3.